Here we're asked to show that the probability of B given A has to be greater or equal to the 1 minus the probability of the complement of B over A. So how do we go about proving this thing over here? First things first, what I try to do is rearrange the left side and the right hand side into something more familiar. We know the rule, the theorem, the probability of B given A is the same thing as the probability of B intersect A over the probability of A. And then the right hand side, I just took the 1, multiplied this one as P over A over P over A, then have a common denominator. And so I have P over A, the probability of A, minus the probability of complement of B over probability of A. And what this does is now I'll cancel these two probabilities of here. And so you'll see I'm only left with the probability of B given A. Sorry, the probability of B intersect A must be greater than or equal to the probability of A minus probability of the complement of B. So we'll see what we can do that to simplify it better. Okay, so what I did is I took the last part of it, B naught, and wrote it as 1 minus the probability of B. And what I can do here is then simplify this equation to have the probability of A plus the probability of B minus 1. And we have this simplified form over here. And so what we need to do is use logic right now to show that this is actually true. So how can you do that? Here. So let me show these two diagrams. Okay, the probability of B intersect A is really when does A and B overlap. In this case, the probability is 0. The probability of A intersect B is 0. These two do not overlap. So this term will be 0. But will 0 be greater than or equal to this term? Let's see. Well, the probability of A definitely is not the whole space, and the probability of B is not, again, the whole thing is less than half of it. So these two will not add up to the sample space. And so when we subtract them, it will be 0, less than 0. But let's assume the ideal scenario. Let's say A was exactly half the sample space and B was exactly half that sample space. In that case, the probability of A is a half and the probability of B is a half. And the reason they don't overlap because I said this has to be 0 over here. So in that case, a half plus a half is 1. But I subtract 1. So again, it has to be less than or equal to 0. So in other words, this term has to be 0 or less because the intersect is 0. And let's see the other scenario. Let's say they did overlap. And let's say it was the whole sample space. In that case, the probability of B intersect A is 1 because A is the whole thing and B is the whole thing. So the intersect of them is the whole thing. The probability of B, A is 1. The probability of B is 1. 1 plus 1 is 2. But when I subtract 1, that's 1. So again, these are the two extreme scenarios. We can see that this side will never ever be greater than this side. It can only be equal or less. I hope that helps.